So, wait, is this working? Yeah, it seems work. So, hello everyone. Thank you for coming to the talk. I'm Shuhei Kitagawa, one of the developers of gRPC Foundation at Mercari. Today, I'd like to introduce our open source project, gRPC Foundation, and explain how we use it to efficiently develop and manage BFFs at our company. The slides are available on the session page, so please check them for links and other details. So let's get started. First, let me briefly introduce ourselves. Mercari runs the largest C2C marketplace in Japan with over 20 million MAUs. We adopted our microservice architecture early on, and we run hundreds of microservices in our environment. We use gRPC quite extensively for inter-service communication. As we have a number of microservices, we began developing a monolithic BFF to deliver optimized responses to clients. However, as more and more microservice teams made changes to the BFF, it grew rapidly, ownership became ambiguous, and the single platform team got overwhelmed by the maintenance costs. So to address this issue, we started a BFF re-architecture project and decided to break down the monolithic BFF. The goal was to have each microservice team create and manage their own BFFs based on their responsibilities. However, this new structure introduces the cost of creating and managing the BFFs by the microservice teams themselves. So to alleviate the burden of developing and managing the BFFs, we decided to develop an open source software called gRPC Foundation to automate as much of the process as possible. In the new architecture, the platform team is still primarily responsible for managing the BFFs as before, but gRPC Foundation makes this process much more efficient. I'll explain it in more detail later, how gRPC Foundation helps with BFF development and management. So what is gRPC Foundation? gRPC Foundation is an open source software to automatically generate gRPC servers by writing custom DSL in protocol buffers. It can be accessed from the following link. It is implemented in Go, and all the generated code is also in Go. It has a plugin system using WebAssembly to implement platform-specific features. With gRPC Foundation, developers can create BFFs by writing only the minimal necessary logic, while gRPC Foundation handles the rest. For example, when you develop a BFF, you'd want to send requests to backend microservices as concurrently as possible, right? If you use gRPC Foundation, it automatically analyzes dependencies between gRPC methods and makes the call concurrently as much as it can. It also automatically sets up essential features for modern applications, such as distributed tracing using OpenTelemetry and logging. Also, gRPC Foundation streamlines the management of BFFs. With gRPC Foundation, since developers create BFFs using the DSL, the dependencies of the generated code, including libraries and external services, can be predetermined. As a result, since it is guaranteed that there is no unnecessary middleware or access to the file system, the platform team can build and deploy all BFFs using common platform framework without worrying about differences between them. Additionally, because there are no unknown dependencies, it becomes easier to maintain a secure operating environment for the BFFs. Since the differences between the BFFs are small, the management team can use the same platform features, such as deployment pipeline and monitoring for all BFFs. This allows a small platform team to efficiently manage a large number of BFFs without focusing too much on each individual one. Before getting into the details, I'd like to briefly compare gRPC Federation with Apollo Federation, a popular framework for implementing a federated architecture. In Apollo Federation, responses are generated through simple schema composition, which requires each microservice to design its schema with the client in mind. In contrast, Apollo Federation, compared to gRPC Federation, has a thinner federation layer, making it easier to manage BFFs without requiring too much automation. In gRPC Federation, a powerful DSL allows the federation layer to handle more complex logic. This enables the federation layer to generate optimal responses for clients with minimal coordination between backend microservices. Developers use a DSL to create BFFs, which makes the generated code more predictable and easier to manage, as I mentioned before. This simplification allows for easier automation and the use of a common platform. For example, at Mercari, a team of 3 engineers supports the entire process from code generation to deployment using a monorepo approach. So now, let me explain how we can use gRPC Federation with a more concrete example. Let's assume you want to create a public API using gRPC Federation. The private post API has a field called secret, and the public post API wants to return a response without the secret field. Yep. So first, let's check the schema of the private post API. We can see that the secret field exists. And next, review the schema of the public post API. It does not have the secret field. Since the private post API is already running locally, let's make a call to it and check the response. So this is a mock response we will receive. It contains the secret field. The main.go file for the public API is set up without any implementations. As you can see, it does not implement any methods. Therefore, when we call it, we receive an unimplemented error right now. Yes, unimplemented error. Now let's go ahead and edit the schema of the public post API. First, we need to import all the dependent plotter files. So import all the dependent plotter files there. Next, use the gRPC Federation service option to indicate that this service will be created using gRPC Federation. Then use the message option to call the private post API and assign the response to a variable named p. Finally, specify how to bind each field of the get post response message. We use a variable p we just defined. You can see that p.id is bound to the id field, and p.title is bound to the title field. Now let's build the gRPC server using gRPC Federation. This time, we will use buff for the build process. When we run buff generate, we see that a new file named post gRPC Federation pb.go is created. Finally, let's edit the main.go file of the public post API. First, we need to modify the main function to use the newly created gRPC server. Next, create a client to access the private post API. Please note that the client interface has already been generated by gRPC server, along with the gRPC Federation, along with the gRPC server. once you pass this client to the gRPC server, all preparations are complete. So lastly, we start the public post API to reflect the changes we just made. And if we send the same request again, we see that the response returned from the public post API does not include the secret field. Oof. I think the slide is gone better. Okay, I think there was a slide there, but let me explain. There are three important perspectives of the gRPC Federation. One is expressivity, the other one is extensibility, and the last one is productivity. So let me explain it one by one. So the DSL of gRPC Federation has high expressivity and can represent complex logic. And this is an example introduced in the demo, where the response of the gRPC method is assigned to a variable named p. And then it is mapped to each field. Here, you don't have to grasp all the details, but I want you to get a sense of how to write DSL. Besides gRPC method calls, the DSL of gRPC Federation supports various features, such as required for service development, such as retries, timeouts, error handling, and conditional branching. I'm not going to introduce them one by one, but if you are interested, please refer to the documentation. One of the key features of DSL is the cell expression, so let me explain it in a bit more detail. So cell is a language created by Google, designed specifically for evaluating expressions. The specification is concise and well-defined. It can be easily extended. It has already been successfully used in various projects, such as Kubernetes CLDs and Proto-CGM Validate. It also offers a high compatibility with protocol buffers. For instance, a cell object can be represented as a protocol buffers message. The lines below briefly describe how to use cell in gRPC Federation. The first line performs a simple calculation, and the second line uses the start with method. Both bind the results of the expressions to the corresponding field. Even though we provide various features through our DSL, we don't believe we can cover all use cases with them. So to ensure extensibility, one feature we offer is a custom resolver. With a custom resolver, you can implement domain-specific logic or use third-party libraries in Go. The example below sets a custom resolver field to true and binds the also field using Go. However, to use custom resolvers, users must maintain both protocol buffers and Go code. Therefore, we recommend avoiding their use if possible. A better alternative to the custom resolver is our WebAssembly plugin system. We have already prepared cell APIs for standard operations like time manipulation. However, if these are not sufficient, you can add your own cell APIs using WebAssembly. By using the plugin system, you can share features among multiple services and implement all logic using protocol buffers. For instance, the example below illustrates our cell APIs for retrieving the current user's ID. So why do we use WebAssembly for our plugins? First, WebAssembly is robust and does not clash the host. For example, if you use Go's standard plugin system, if the plugin crashes, it can cause the host to crash as well. However, this does not happen with WebAssembly. Secondly, WebAssembly is secure, and the host can easily restrict plugin capabilities, such as network access and file access. This means even with plugins, gRPC Federation maintains its advantage in preventing unexpected behavior in BFFs. Lastly, WebAssembly is portable and can run anywhere once it's built. By embedding the built WebAssembly into a Go program, you can preserve the advantages of a single binary, even using plugins. We also provide various tools and documentation to improve developers' productivity. We have created a language server to help developers write the DSL, and it can be used with VS Code and the JetBrains plugin if desired. We also offer a linter and a standalone generator for quick use of gRPC Federation. We provide detailed demo documentation to showcase real-world use cases of gRPC Federation, along with API references. Lastly, let me talk about the current status of gRPC Federation. gRPC Federation became generally available in June, so it can be used widely. gRPC Federation is an open source project, and we would love to develop it together with the community, so contributions are always welcome. At Mercari, we have developed over 16 BFFs using gRPC Federation, and 3 of them are already in production. It currently supports more than 100 gRPC endpoints, and for example, one service collects 6 endpoints with 800 lines of protocol buffers and 300 lines of DSLs. So that is all from us. We hope gRPC Federation expands the boundaries of gRPC even further and contributes to the community by addressing use cases that haven't covered yet. Masaaki Koshima is a lead developer of gRPC Federation, and he's also here to talk with you. So we are happy to answer your questions or discuss your use cases. I'm Shuhei Kitagawa, a developer of gRPC Federation. So thank you for listening, and we look forward to talking with you. Thank you. Questions?
I'll just ask for the recording.
So one question I have is, if we're consuming multiple services, say we want to take 2 or 3 services and aggregate a bunch of data and manipulate it before sending it out, I'm guessing there's a plugin to handle that, or?
You can use, actually, I didn't explain it explicitly, but all the responses you receive can be used in cell expression.
Okay.
So in the example, the variable P is an expression, so we bind the response to the variable P, and you can use it in the cell expression. So you can bind the variable P to each field.
Okay.
As you wish, yeah.
Thank you.
And you can call multiple APIs in the message option, so that's how we handle it, yeah.
Okay. Thank you.
Sure.
Thank you.
Any questions? Looks good. Oh.
So you have these APIs that you mix together in Federation. Do you have a catalog of those APIs? Like, how do the developers know what APIs are available to them?
In our company, we manage all the protocol buffers in monorepo, so that's how people know how to use each APIs. But I think that depends on the companies, yeah. But that's at least how we manage all the.
Do these APIs that you produce go back in that monorepo so they could be remixed? I mean, I don't think you want to have federations of federations, but I suppose that's possible, right?
Yeah. Sorry, would you repeat your question?
Well, so when I use Federation, I'm basically creating a new API.
That is correct, yeah.
And someone could federate that.
Technically, yeah, I think that's possible. That's possible, but right now, I think I've never seen the use cases, yeah. But if you try to do that, I think it's possible, yeah.
Right, it would just be slower, I guess. Like
Yeah,
at some point
I
it's
don't
too
think it's
slow.
optimal in terms of performance, yeah. Thank you. So I think that is all. Question? No. Okay, we're gonna stay here a while. So if you have like questions, like you want to ask personally or discuss your use cases, so please feel free to reach out to us. Yeah. Thank you so much. Yeah. Thank you.
Thank you.